Hello everyone, in this video we are going to discuss how to conduct the tensile test on the tensile specimen by using universal testing machine and ultimately draw the stress strain curve for the material which is gradually loaded by using tensile load. Okay. Now first, the test is conducted in this machine, that is UTM, universal testing machine, and as you can see, this is the dial gauge which represents the load, okay, which gives us the measured load, and this is the way to control the load. These are the control buttons, and this is the platform where actually the loading takes place. And let me show you the specimen. Now this thing which you are seeing right now is the specimen, and this is the basically tensile test specimen made up of mild steel, and this is its gauge length. This is its gauge length, and gauge length here is 50 mm. Okay. Now, as you can see, it is fixed between the two jaws of the universal testing machine, and here we fix this jaw and we move this jaw in upward direction, or basically after we load it, this jaw gradually goes on moving in upward direction so that this specimen is loaded gradually. Okay, and while this happens, while the loading happens, the deformation is measured by this extensometer which you are seeing in mm. Okay, and here the loading is done gradually at the interval of 1.25 kilonewton and in the steps of 1.25 kilonewton. That is, first load will be 1.25 kilonewton, and then we go on increasing till 40 or that kilonewton. Okay, 45 kilonewton. Okay, and what happens is, while this happens, this will go on elongating a bit. Okay, and gradually we'll find out the necking in this portion, and then there will be slight cracking, and ultimately the specimen will fail by cup and cone arrangement. Now I show you this failed specimen here. The failed specimen looks like this. As you can see, it looks like the cup and cone arrangement. This is the failed specimen. Okay, this is the failed specimen. Okay, so basically when this happens, we go on we go on increasing the load, and simultaneously we keep on noting down the deformation values. Now here, the main things under consideration are: the observation that we do here is the gauge length, which is 50 mm, initial diameter, which is 11.6 mm, which is measured, and then the stress can be found out by P by A, where P is the load applied and A is the original cross-section area, and strain epsilon is delta L by L, that is change in length to original length, that is ratio of change in length by original length. And we take at least 40 observations here, basically 40 readings. As you can see, it consists of serial number, then applied load, which is in terms of kilonewton, and then there is a deformation in terms of mm, then stress found out from this formula, and then strain, okay, and then strain, which is found out from this formula, and ultimately we find out the Young's modulus by taking out the slope of stress versus strain curve that we form under the proportional limit. Okay, that is nothing but the Young's modulus value for the material. Okay. So this is how this test is done.